So now it's high time we solve this. Now, how do we get the tension in the pendulum? For us to get the tension in the pendulum, don't forget there's a tension here. So for us to get the tension in the pendulum, we could use the force of tension along x-axis, or we could also use the force of tension along the y-axis. So if we choose to use the force of tension along the x-axis, we could do it in 2 dimensions, or 2 ways. If you choose to use the force of tension along the x-axis, that means we're going to use this force of tension, which is mv squared over radius. Now that, first of all, it means we have to get the velocity. Now, how do we get the velocity? There's a velocity here. V squared equals to GL sine theta, or that is tan theta, or V squared equal to GR tan theta. Now, we are not given the radius. We can easily get the radius. The radius is L sine theta. So let's use this. This is the best we could use. So we want to get the velocity. So what's going to be the velocity? Velocity is equals to the square root of gravity. What's gravity? Gravity is 10 meters per second squared. That's well known. 10 times, what's the length? The length is 3 meters. The length is in the right unit, 3 meters. Then sine, what's the angle? Sine 40 degrees times tan 40 degrees. So velocity is equals to, quickly, we're going to use our calculator to solve this. So velocity, which is a gravity, times length. The length is 3 times sine theta times tan theta. So let's quickly do that with our calculator. Square root of 10 times 3 times sine 40, then times tan 40 degrees, will give us 4. So the velocity is 4 meters per second. This velocity we have here. So this very pendulum moved, with a speed of 4 meters per second. This velocity is a linear velocity. Now, after we've gotten this velocity, now quickly, don't forget we are using this. We want to use this first. So what's going to be the first force of tension along the x-axis? Force of tension along the x-axis is mass times velocity squared over radius. Now let's move on. Force of tension along the x-axis is equals to the mass. What's the mass? The mass we're talking about here is 5 kilogram. The mass is in its right unit, times velocity raised by 2, v raised by 2, over the radius. What's the radius? The radius was not given, but we can easily get the radius. The radius is length times sine theta. What's the length? 3 times sine 40 degrees. So let's quickly use the calculator also to make this very quick. What do we have? We have 5 times 4 raised by 2 is 16, divided by 3 times sine 40. That will give us 41.48. 41.48 is about, let me say 41.485. 485. So let's say that's 41.5. Let me use that. It's 41.5. Now,